Lesson 3.3 on constructing perpendiculars. Now, first let's discuss what a perpendicular is. A perpendicular is a segment perpendicular to another segment, ray, or line. And remember, perpendicular lines or angles are angles that cross at 90 degrees. So anytime you have yourself a segment, say segment AB, and there's another segment, any one of those three in blue, that actually intersects or crosses segment AB at 90 degrees, regardless of its positioning, that constitutes a perpendicular. Now, if you have a line and a point not on the line, what is the shortest length from the point to the line? For example, given in that diagram, point H and segment CD, what is the shortest distance from H to the segment? Well, we could certainly draw a line from point H to point C, or a line from point H to point D. But you'll notice actually that each of these lines that we draw somewhere to the segment gets closer and closer to the segment up until we get to the perpendicular itself. In fact, that's exactly what the shortest distance conjecture says. If you are given a line and a point not on the line, then the shortest distance from the point to the line is along the perpendicular through that point. In addition, oftentimes you will hear a reference to the distance from a point to a line. Anytime there's a reference to the distance between a point and a line, or a point and a line segment, it is referring to the perpendicular itself. Now, to construct the perpendicular, we begin with the following premise. We're given a point and a line, or a line segment, and we're asked to construct the perpendicular from the point to the line. Now, in order to do that, we begin by pivoting our compass on the point, in this case point C. And then extending our compass far enough to sweep across the segment, we sweep an arc across the segment, like so. We just have to make sure that when we do our arc sweep across the segment, there are 2 points of intersection between the arc and the segment. Step 2, keeping the same gap in your compass. It's not necessary, but it's helpful. It's just one less thing to have to worry about. Pivot your compass on the points where our original arc meets the segment. Make 2 arc sweeps below the segment. So we'll first take our compass and pivot it on one of those points where the arc crosses the segment, make a little arc sweep below, and then on the other point where our original arc met the segment, and again, make a little arc sweep below. And our goal here is to actually find a point that is equidistant from those 2 points that we made from the arc. Where those 2 arcs intersect is our second point from which we can draw a perpendicular through from point C. So our final step involves taking our straight edge, lining it up with C and the point where those 2 arcs below intersect, and drawing our perpendicular. Now there are certain special perpendiculars that you need to be aware of. The first special perpendicular is what's called an altitude. An altitude is a perpendicular that's drawn from the vertex of a triangle to its opposite side. And altitudes can consist of 3 different styles. The altitude may actually be within the triangle itself. Anytime you have an acute angle, all 3 altitudes in the triangle will be inside the triangle. But an altitude could also possibly be outside the triangle. For example, given this obtuse triangle here, if we try and draw an altitude, we'd actually be outside the triangle. And in order for us to actually draw the altitude, we have to extend one of the sides beyond the vertex of the triangle. And then, and only then, can we actually draw ourselves a line that's perpendicular to that extended side. Also, if we actually have ourselves a triangle that is a right triangle, then one of the altitudes will actually be the edge of the triangle itself. Thus concludes today's lesson.